everyone. Good day. This is Professor Roger Flores of the Department of Electrical Engineering, your professor of the subject E30, the Electrical Engineering Utilities. Okay. So for today, let us discuss about Chapter 4. It is entitled Light and Architectural Lighting Systems. Okay. So this chapter will discuss different principles in the architectural designs, the background and historical background of the lighting system, the architectural lighting systems, and the rest of the principles of the lighting systems. So to begin our discussions, we have here the Light and Architectural Lighting Systems, Chapter 4. Okay, so this is the content of our discussion for this chapter. So we have here a chronicle of artificial lighting, elements of seeing, lights, or the color of light, so on and so forth. And then the last topic here is daylighting principles. Okay. So as for our introduction, we have here lighting accounts for 20 to 25% of the electricity consumed in the United States and even in Canada, and almost 20% for the rest of global electricity consumption. Okay, so this is the fundamental reasons for providing light in space, okay, to make the object in the space visible. So that is the important thing that we should know, that we need lighting so that we'll be able to visualize, or any object, it will be visible in our eye, no? So and to conduct activities that must take place in the space, no? Good architectural lighting provides the right quantity of light with excellent color radiation and minimal glare. Okay, quality lighting has been shown to improve productivity and enhance worker satisfaction. Okay, so this chapter also introduces basic lighting terminology and the procedure of simple lighting design. Okay, so this presentation highlights the materials that acquaints the technician with basic design principle. Okay, so the subtopic 4.1, this is a chronicle of artificial lighting. Okay, but before that, we have this historical perspective. So as we know, light has played an important role in human activity. Okay, it's very hard for those who cannot see light, or for those who have a problem in seeing, no? So especially for those who are blind. So it is therefore very important that we will be able to see, so that it will improve our life, no? Then until the early part of 20th century, people have relied on the natural lighting. Okay, so what are those sources of natural lighting? So it will be wood, candle wax, okay, whale oil, coal gas, and even kerosene. Okay, with the advent of electricity and incandescent lamps, communities started switching to the most safer, cost-effective electricity-powered lighting, and this is now the what we call as artificial lighting. Okay, so we have this unit of illumination, okay, which is until now it is still being used, no? So we have this foot candle, the unit of illumination. Then we have this German chemist invented this more efficient vacuum pump in 1865. Okay, It was critical to the development of incandescent light bulb. Okay, so this German chemist in the person of Hermann Sprengel. And then we have this another scientist were able to develop this working incandescent lamp, no, in a person of Joseph Swan. Okay, so light bulb using carbon filament lamp, and it was February 5, 1879. Then this is a very we are very familiar to this person, Thomas Alva Edison. Okay, he was the first person who announced the successful development of an incandescent lamp with baked carbonized cotton thread filament, and it was during the 1879, December 21 to be exact, no. So he first developed the commercially feasible electric light low-cost lamp that could remain lit for a long period of time. Okay, in 1882, Edison Electric Light Company, which is later known as Consolidated Edison Company, powered incandescent street lights and lamps, no, of London and later in United States of America, particularly in New York, no, which serve as a model of for future utilities. So talking about these utilities, we have the Niagara Falls Power Company. This is a hydroelectric power plant, and was built or operated, started August 26 in 1895. Okay, and later we have in 1939 the GE or General Electric introduced fluorescent lighting lamps, no, or light fluorescent lamps, no, an electric light source that is more efficient than the incandescent lamp. Okay, so it is understood, and we knew that incandescent is not more efficient. So compared to fluorescent lamp, which is more efficient. Why? Because this incandescent later they know that only 5% of the power input will be converted into light, and 95% is converted into heat. So that is why this fluorescent is more efficient than the incandescent bulb that was discovered by Edison. Then we have some professional organization which develop technical standards, okay, of these lamps, no, technical standards, specifications, and design techniques, no. So some of these are this Illuminating Engineering Society of North America, IESNA, then also the LELD, then we have the NEMA and the ALA. So these are some of the professional organization that develop the standards, specification, and the design technique of these lamps. Okay, so we have also this standard and codes, no. So one of the code that we have is the National Electrical Code, or NEC. Okay, so this is the model code that specifies the minimum provisions necessary for protecting people and property. Applies to both the manufacturer and installation, and most municipalities and countries require that residential and commercial electric wiring conform to this NEC. Okay. Then we have this American Society of Heating, Refrigeration, and Air Conditioning Engineers Incorporated, or Illuminating Engineering Society of North America Incorporated, Standard 90.1. Okay, so this address energy consumption in commercial and high-rise residential buildings. When we see high-rise residential buildings, this includes the skyscrapers or these condominiums, no. This standard is for the the refrigeration and air conditioning, no, and other related devices. This sets minimum performance standards for building systems and components that have an impact in building energy consumptions, including building envelope, heating, ventilation, and air conditioning, or HVAC systems and lighting. Okay, so we have also these elements of seeing. Okay, so this is we have here to discuss the some of these element or the condition. So depending on a person who will see or watch the efficiency of lighting system. So we have here design of a good lighting system involves application of a blend between scientific principles, artistic skill, and design experience. Okay, so we have this word optics. Okay, this is the branch of physics that relates to the properties of light and the function of vision. It involves study of the human visual system and how it interacts with light. So the basic principle of vision and light as related to building lighting systems will be introduced. Okay, so we have this visual system that we said, no? So we have here the visual system of a human is composed of the eye, the optic nerve, the and certain parts of the brain. So the eye as the window, the nerve as our transmission medium or media, and then the brain that will analyze or will perceive, or when it comes to color and the visibility of the object. The eye is the organ that allows a human to sense light and produce electrical impulses that will be sent through the optic nerve as I've said, the medium of transmission to the brain. And this brain, that part of the visual system where the impulses are processed, no? So the signal, meaning the signal will be processed so that we'll be able to the brain to give an idea what is the color or the lighting system is all about. Okay, so let's discuss first the eye. Okay, so we have this illustration of the eye. This is the ball. No, we have this is the retina here. So this is the retina. We have the optic nerve. This will be connected to the brain. Then the iris here, the lens. Okay, the iris at the other side, and the cornea. Okay, so the eye functions much like a simple, very crude camera. Rays of light pass through the transparent cornea of the eye and through an opening called the pupil. Okay, so we have this iris. Okay, what is this iris? This iris surrounds the pupil. So we have the iris here, no? Surrounds the pupil and adjusts for the amount of light available. So it will adjust to the amount of the light that's sensed by the lens, no? So it opens and closes to control the quantity of light, and the interior of the eye receives, much like the aperture of a camera, opens and closes to limit the light to which the film is exposed. Okay, so that is all about iris, no? Then we have this lens, no? This lens is a transparent ellipsoidal. So we have here, no? So ellipsoidal, that ellipsoidal medium that changes thickness. Okay, allowing it to bend and focus the rays of light entering the interior of the eye. Okay, the lens thickens to focus rays of light. from objects nearby and narrows to focus light from distant objects. No? So the lens concentrates the rays of light on the retina and a membrane on the back of this eye. Okay, so we have this retina. It is composed of nerve cells. Okay, we have here the retina here. This composed of nerve cells within the photoreceptors that are shaped like rods and cones. No, these photoreceptors do not discern color well, so dimly lit objects are perceived as being uncolored, that is, seen in shades of gray. Okay, so if you have this, if the amount of light or the color is not so clear, so if it is not light, no, like for example black or gray or a dark color, then we have this photoreceptors will try to change the color and it will be darker. No? Okay, so we have here the three types of cone-shaped photoreceptors, okay, in the retina. So this is each type responds to one of the primary colors. So what are those primary colors? So we have this red, green, and blue. Okay, so we have about 5% of the population, mostly males, has defective color vision. Okay, so usual having a problem in the color, the vision of the color are those who are females, no, males, no, for about 5% of the population having this problem. Then we have this color blindness, no. What is this color blindness? It is the inability to distinguish colors, no. So meaning to say that if you are not so sure with the color, it is either red, green, or blue. Then if you are not so sure, then you might have some problems in color, to distinguish the color, and you might have this problem, the color blindness. Okay, so they tend to see reds and green as yellow, no? So if you can see that red and green as yellow, then there is something wrong with your eye, and you might be one of the victim of color blindness. Okay, so next subtopic here is light. So this light is a form of energy. Okay, we have this a form of energy known as electromagnetic radiation. Travel as an electromagnetic wave. No, light travels through the vacuum of space. So when we say vacuum of space, so it is not influenced by other outside or external forces, no? So it is in the vacuum of the space, no? So unlike sound, this light will travel more or less 300,000 kilometer per second. Okay, so more or less 300,000 miles per second. Okay, more or less. Then we have this electromagnetic radiation. This is an energy radiated in the form of wave caused by an electric field interacting with the magnetic field. Okay, so results of the acceleration of charged particles, and then categorized by wavelength and frequency. So this wave, this electromagnetic radiation or wave is categorized by either wavelength or frequency. So this is the illustration of this wavelength, no? So as we define that it is measured as the distance from one peak of one wave to the peak of the next wave. So this is the positive peak, for example, of the first wave, and the next wave here, this is the next positive peak. So this is the distance between these two is called wavelength. Okay, So we have also this frequency, so this frequency is the number of wave cycles per second. So for example, if these two cycles here are done within 1 second, then we have this 2 cycles per second. So we have, if we have this 2 cycles per second, we can say that it is 2 hertz, no? For example. So television and radio waves are several meters long with frequencies ranging from 10 kilohertz to 300,000 megahertz. Okay? So for that TV, okay, sa mga TV, television, sa mga radios, then we have that in kilohertz, for especially if we have this EM, the amplitude modulation, and for the FM frequency modulation, it will be in the megahertz, no? Most light sources emit electromagnetic radiation composed of different wavelengths of light, no? So sunlight striking, for example, the sunlight striking the Earth's outer atmosphere is made up of ultraviolet about 5%, visible light about 45%, and infrared about 50% radiation. So that is why thou shall not see directly the sun, because you have all these radiations that you will be receiving. Okay, 5% of it is ultraviolet, then only 45% is the visible light, and another radiation, we have this infrared radiations, it is more or less 50%. Okay? Now, we have this classification of electromagnetic radiation in spectrum. Okay, so it is by wavelength, no? It is by wavelength. So, this is full light spectrum and the visible light spectrum. Okay, so this is the conversion of 1 nanometer to meter, no? So, next we have this, the equivalent wavelength per color, no? So when we say violet, the wavelength of violet is 380 to 450 nanometer. So we have the blue, the green, the yellow, and the orange. And red here is 620 to 750 nanometer. So wavelength ranges of visible light by color. So that is why we have this different color here. Visible light is the wavelengths of electromagnetic radiation spectrum to which the human eye is sensitive. Okay. We have here the visible light that we said, no? So part of electromagnetic radiation spectrum capable of exciting the retina and ultimately producing visual sensation. It is the wavelength of electromagnetic radiation to which the human eye is sensitive. So we have that visible light. We have also this behavior of light. Okay, so when light strikes a surface, the surface will be illuminated. Okay, so illuminance is the amount of light incident on a surface, and then luminance is how bright an object appears. So when this object is stricken by the light, then the amount of brightness that with this object emit is called luminance. Okay? So we have also this reflectance, no? It is the ratio of reflected light versus the light striking the surface. So we have this reflected light. So we have, this is what we call as reflectance. The amount of light that reflected by in the by striking the surface, no? So this is the reflected or the reflectance here. Okay, so we have also the transmittance, no? It is the ratio of light. So this is the light transmitted. Okay, transmitted, no? Because this is the ratio of light transmitted through body to light eliminating surface. Okay, so we have this transmittance. Okay, then we have also the absorptance. No, it is the ratio of the light absorbed versus the light striking the surface. So whatever the light absorbed by the surface of this, for example, this is the glass, no? So whatever the amount absorbed here, this is called absorptance, no? Absorptance. Okay. Next, we have here the color of light. So, have you seen the color of light? So, it depends upon how you perceive the reflected or the emanated the light that is illuminated in the object, no, in the object. So we have this color perception. Okay, so accordingly, color perception is the ability to distinguish and interpret determine different wavelengths of visible light. Okay, so ability to distinguish and interpret different wavelengths. Okay, so for example, for the artificial and natural light, sources are composed of many wavelengths having varying magnitudes. So depende po 'yon sa kung ano ang color that is illuminated with these objects, okay, or the visible lights, no? So artificial and natural lights sources are composed of many wavelengths, no, and magnitudes. Okay, so an opaque object will selectively absorb different proportions of these wavelengths and reflect the remainder towards the viewer. Okay, so we have here a light source, a source producing a blend of wavelengths. Okay, so as we said, no, this light is actually made up of all wavelengths of visible light, contains the individual red, green, and blue. Then primary colors of light are additive. They can be used in various combinations to produce other color by adding colors. Okay, so if you're going to add other colors like blue, for example, blue and green, then it will result to this cyan. Okay, so if there is a combination of red, blue, then we have the yellow, the green, and the cyan, then it will result to white and any other combinations, no? Any other combinations of the major colors and the minor colors. Okay, so it will produce another color. Then we have these different types of lights. Okay, so we have the monochromatic light and or chromatic light. Okay, if you have only one color, this is called monochromatic light. And if we have having different colors, then we call this one as chromatic light. So we said that chromatic light emits a fairly even distribution of all wavelengths of light. So since we have all and it is distributed fairly or emits fairly, then it will create several colors, and we call this one as chromatic. So most light sources are not fully chromatic. So we have also this monochromatic now. So type of wavelengths emitted by a light source will influence, of course, the color. Okay. Then we have also the color quality. A light source that produces a blend of wavelengths evenly distributed across the light spectrum is perceived as white light. Okay. And then white light renders all colors. Okay. Generally, good quality light sources renders all color uniformly. Okay, so when these colors are distributed uniformly, then you might have a good quality of color. Okay, so a light source of poor color quality renders a different colors unevenly. Okay, so we have these two methods used to rate the quality of color. Okay, so the color temperature and the color rendering index, or CRI. Okay, so this is the two methods used to rate the quality color emitted by light source, or for example the lamps, no? So we have also this visual acuity. So visual acuity is the ability to distinguish fine details of the light or colors. Okay, it is the keenness of visions that is necessary to perform tasks such as reading, writing, drafting, and many other activities. So technically, visual acuity is measured as the ability to identify black symbols like letters on a white background at a specific distance as the size of the symbol varied. Okay, so subtopic 4.5, let us discuss the characteristics of artificial lighting. Okay, now let's discuss the all about artificial lighting. So, talking about artificial lighting, it is this includes the lamps, the bulbs, or whatever lamps that we use, and then the luminaires, and then the lighting or the light fixtures. Okay, so what is lamp? It is a device that generates light. So any device that generate lights, then that is a lamp, no? Common misconception of a lamp and a light bulb is that the light bulb is simply the glass portion of a lamp that is encloses and protects the working parts of the light source, while the lamp itself is the source of light. Okay, so the source of light is the lamp itself, and the bulb, or the bulb is the external glass that will protect the lamps, no? Okay, so this is the categories of lamps: the incandescent and the gaseous discharge lamps. Okay, so this is an example of the gaseous discharge lamps. We have the CFL, and this is the incandescent lamps. Okay, so let's talk about incandescent lamps, no? So this kind of lamps provide light source by incandescence, no? Which is the emission of light caused by heating the filament. So this is our filament here inside the bulb, no? We have the filament here, and this filament will be heated. Okay, so this will produce light, no, when this is heated. Okay, then for the gaseous discharge lamps, okay, so this is categorized into two more subcategory: the low pressure and the high intensity discharge, or HIDs. Okay, HID. The low pressure discharge example of this is fluorescent lamps and the low pressure sodium lamps, or also the this CFL, or this CFL, no, the fluorescent lamps, no, similar to these fluorescent lamps. Okay. Okay, by the way, the low pressure, okay, we have also the high intensity discharge, like mercury B4 lamps, metal halide, and the high pressure sodium lamps. Okay, we will discuss this one by one. Okay, so before that, let us talk about this luminaire. So it is a complete lighting unit which consists of lamps, lamp sockets, any lenses, refractors or louvers, or ballast, and the housing. So all the set of this lamp, okay, one set of this lamps with receptacle, sockets, lenses, refractors, louvers, then ballast if we have, then this is what we call as luminaires. Okay. Then we have also this light output. So luminous flux is the measure of the perceived power of light expressed in lumens. Okay, so this is the luminous flux that we said. Okay, it is expressed in lumens. No, so lumen is defined as the quantity of light. Okay, so given out through a steradian by source of some candela of intensity radiance equally in all directions. So we mentioned about candela. So it is the international standard unit of luminous intensity. So it is using the unit candela. No? Okay, so that is the power emitted by a light source, a lamp or a bulb source in a particular direction. Candela is the luminous intensity and a given direction. So let us talk about luminous efficacy or this light efficiency. No? So luminous efficacy is the ratio of the light output and a light source, no, to the light energy consumed to produce light source. Okay, so it is the ratio between the light output and a light source. Okay, so it is expressed in the unit lumens per watt, no, lumens per watt, or LM per W or watt, no, and thus typically referred to as LPW, meaning light output power. No, so we have this example here. No, determine the luminous efficacy of a 40 watt incandescent lamp that emits 505 lumens of light, and determine also. Okay, so the what do you call this one? The light output, okay, the lumens per watt or LPW. The lumens per watt is the produced or emitted amount of light in lumens divided by the watt, the input power in watts. No, so 505 lumens per 40 watts. Okay, so it is more or less 12.6 lumens per watt or LPW. Okay, so next we have this correlated color temperature. Okay, so color of light that emitted by light sources correlates to the temperature of the emitting source. No, so according to physics, okay, so we have this what we call as theoretical ideal body that perfectly radiates energy. So we have that, no? So technically, color temperature only applies direct to light sources that incandees or emit light from heating, such as the ordinary incandescent lamp. Okay, so we have this correlated temperature. So as we know that the power or increases, the current increase, then the temperature will also increase. They are directly proportional. Then we have CRI, so we call this one as color rendering index, no? Color rendering index we have here, no? Okay, so the color rendering index is a method of numerically comparing the color distribution, okay, of light source to a reference lamp. Okay, so reference lamp emits light over the full visible light and spectrum at the same color temperature. Approximate CRI values for different commercially available lamps, no? So in theory, a lamp with a higher CRI or color rendering index more closely emulates the reference lamp and provides a better color rendition. Okay, so we have this spectral power distribution data. No, what is this spectral power distribution? It is a graphic presentation of the quantities of light emitted by a lamp by wavelength component. No, these curves are plot of radiant power versus a specific wavelength across the light spectrum. They provide visual fingerprint of the color, characteristics of the light emitted by the source over the visible part of the spectrum. Okay, so spectral power distribution curves for specific lamps are available from the manufacturer. So the manufacturer will provide these curves so that we'll be able to specify or determine the power distribution of these specific lamps. Okay. So, lamp life. Okay, so this is the rated life of a lamp, and is median is its median life expectancy expressed in hours. No, so it is the cumulative time that lapses before 50% of representative groups of lamps has failed, and the other lamps in the group continue operating. So we have this what we call as lamp life. The unit of it is it should be expressed in hours now. So we have this example class. Okay, so try to what we call this one, study this example that we have to determine the lamp life. Okay. We have also the depreciation of lamp output. Okay, so the luminous flux will decrease, no, when this lamp operates. So as the lifespan of our lamp reduces, so the luminous flux also reduces, no. So as incandescent lamp operates, their light output degrade to about 85% of lamp's initial lumen output, then also the lighting also will decrease. No? So with the fluorescent and this HID lamps, the lumen depreciation will vary by lamp type, size, and use. Okay, so we should have to consider also the depreciation of the lamp light. Okay, so we have this 4.6 types of artificial light sources. So what are these light sources, artificial light sources? So we have these incandescent lamps, no? So we heard this one already. It was introduced by Thomas Edison, no, in 1890s. Then when he successfully introduced the basic design of this lamp and light bulb, no, and it is incandescent lamp, as we said. Okay, so we have some advantages of these incandescent lamps or bulbs. The low lamp cost, so medyo so ibig sabihin na low cost lang siya, ano. So then it is also reliable, and this is very familiar to us, common in the market, and have good color rendition. Okay, so we have also disadvantages now. Short rated life. So the lifespan is shorter. Then we have poor efficacy. Okay, and lumens per watt, no? So the efficiency of producing light is less, no? Okay. So this incandescent lamp also is designed to balance between efficacy and lamp life, no? The hotter the filament, the more efficient the lamp is converting electricity into light, and the whiter the light. Okay. So incandescent filaments can reach temperature of between 4,600 and 6,000 degrees Fahrenheit. Okay, electromagnetic radiation from filament includes a significant amount of visible light, mainly in red, orange, yellow wavelengths. Okay. So, as an incandescent lamp burns, the filament evaporates and deposits in the inner surface of the glass bulb. About 85% of lamp's initial output reduce the light output. So, we have this what we call as reduction of the emitted lights. No? So, filament can be operated at higher temperatures with chemically inert fill gases such as argon, krypton, or xenon. Standard incandescent lamps come in an assortment of wattage, voltages, shapes, and types of base or the bases. Okay, so incandescent lamps have wattage between 3 to 1,000 watts and voltage of 6 to 277. And even 120, 125, 130, and here in the Philippines we have 230 to 250 volts. No, so these are the voltage rating of our incandescent bulbs. Okay, so the base is also either threaded or pin type. No, okay, so we have the medium base, we have the candelabra base, and the mogul base. So we have these different types of bases or base of this incandescent lamp. So we have also special use incandescent lamps, okay, are available. We have the long life lamps, rough service lamps, plastic coated lamps, and low voltage lamps. Okay, so we have all those types of incandescent bulbs. Next lamp that we are going to discuss is the tungsten halogen lamps. Okay, this is frequently called as halogen lamps. Simply halogen lamps. No, a smaller, brighter, and more expensive version of incandescent lamps. Okay, this contain high pressure halogen gases. Okay, it is either iodine or bromine. Okay, allow the tungsten filaments to be operated at higher temperatures and higher efficacies. But of course, we have this high pressure so that these tungsten filaments will not be burned out or busted. Okay, so advantages of better color rendition, more light output, and longer life for these tungsten halogen lamps. Okay, this generate intense heat and require adequate clearance and good ventilation of for heat dissipation. Otherwise, if we will not control the temperature, the ventilation, then of course the lifespan of these tungsten halogen lamps will be shorter. No, it cannot be touched because of course the glass or the bulb is very hot. No, so this will depositing residual skin oils that substantially reduce the life of the quartz glass bulb. Okay, so talking about the gaseous discharge lamps, this is electricity passing through a gas such that it causes the gas to arc or spark. No, so it produces continuous light by passing electricity through a gas contained within the lamp. Okay, so this will produce ultraviolet radiation that causes a phosphor coating on the inside of the lamp to glow. Okay, so there is what they call as ultraviolet light radiation within the lamps, no? Then which will cause the phosphor coating. Okay, that's something like a white powder coating of the glass. Okay, inside glass will glow, no? Unlike incandescent lamps that produce light by getting a filament hot. Okay, so gaseous discharge classification, we have the fluorescent, the mercury vapor, metal halide, and low and high pressure sodium lamp. These are considered as gaseous discharge lamp. Okay, so what is a ballast? No, ballast. I think you heard about ballast, no? Especially if we are using fluorescent lamps, no? Additional service that is required to all gaseous discharge lamps, no? A voltage transformer and a current limiting device designed to start properly control the flow of power to discharge light source such as fluorescent and this high pressure HID lamps, no? It can consume up to 20% of the electricity used to power a luminaire or the whole set of these lamps. Okay. So we have these different types of ballast. We have the magnetic or iron ballast, which is the most common one. We have also the electronic ballast, the solid state electronic components, no? So this is to minimize noise. Okay, compared to this magnetic ballast, it might have it will produce vibrations or the noise through vibrations, no? So we have also this ballast noise, no? Extremely annoying in a quiet spaces. So we have also the ballast factor. It is calculated by dividing the lumen, the output, lumen output of the lamp ballast, combination by the lumen output of the same lamp and a reference ballast, no? Ballast and lamps should be matched so the luminaire can produce the largest light output. Okay, so another type of lamps is lamp is these fluorescent lamps, no? Composed of a tubular glass bulb that is covered with a thin phosphor coating or the white powder in the glass bulb, no? Inside the glass bulb, no? So, or inside surface. Glass bulb is filled with a low pressure gas containing mercury vapor. We have also this cathode are filament-like coils at the end of the fluorescent lamp, no? That act as terminals for the electric circuit. So these filament-like coils will be produce heat. Okay, so this will produce light, no? And this is the source of light, no? Okay, so we have the different linear fluorescent lamps. We have the T12, T10, T8, T6, T5, T9. So this depends on the diameter and the length of the tube that we have. Okay. So we have also the high output and a very high output fluorescent lamp, no? High output and very high output fluorescent lamp. So we have also this CFL, the compact fluorescent lamps. It is more or less, of course, from the word itself, more or less the characteristic will be or is the same or similar with that fluorescent lamp characteristic. No? Okay, are miniaturized is fluorescent lamps. So when we say miniaturized, it is more compact and it is more smaller with specific or similar power or lumens output. Manufactured with integral ballast and standard screw base that can be installed in standard light fixtures or luminaires. Okay. Then we have these different categories, okay, or standard sizes of these CFLs. No, we have the 7 watts, 11 watts CFLs, 13 watts, 19 and 23 watts. Okay, so with the equivalent incandescent lamp power, no, the 7 watts of the CFLs will replace 25 watts of the incandescent bulb. 11 watts of the CFL will replace the 40 watts of incandescent bulb, and the 23 watt CFLs, the compact fluorescent lamps, will replace the 100 watt incandescent lamps. No, so meaning to say that of course this CFL is more efficient and more saving, power saving or energy saving device or lamp source, no? Okay, so we have these fluorescent light fixtures. It will depends on the variety of shapes, wattages, and voltages. Okay, so we have here has the variety of colors: daylight, cold white, soft white, warm white, and deluxe warm white. So fluorescent have the different types of colors, and of course, the phosphor blended and the fluorescent lamp determine the color temperature and color rendering or CRI of the lighting emitted by the lamp. Hollow phosphors are the most popular, least expensive, okay, and lowest quality phosphors. These hollow phosphors. All fluorescent lamps are designed to operate at a specific air temperature. Okay, so talking about fluorescent luminaire, luminaire efficacy rating or LAR. So it is the ratio of light emitted by the fluorescent luminaire to the electrical energy consumed, including the ballast. Okay, so comparing the luminaire efficacy rating of two luminaires is not quite as simple as comparing the APA. Okay, or the mileage rating of two different automobiles. It is not as similar to that. It is more complicated or complex when it comes to luminaire efficacy rating. Okay, so we have this example here. So just review the solution on how we determine the LER of the lamps. The low efficacy rating. High intensity discharge lamps, or we call this one as HID, high intensity discharge lamps or bulbs. Okay, so this includes mercury vapor, metal halide, and high pressure sodium lamps. Okay, so how this differ from fluorescent lamps? Okay, so these high intensity discharge lamps, okay, gas is under the high pressure compared to the fluorescent lamps. It is having more or high pressure. The gas is having more pressure compared to the fluorescent lamps. The lamp is specifically smaller compared than that of the fluorescent lamp. Okay, so it is high lumens, high intensity light, but the physical figure is more. It is more smaller compared to fluorescent. Okay, so some of the components of this HID lamps, they have the internal arc. The tube contains the filled gas here. We have the tube. Okay, the large outer. Okay, by the way, this is the internal arc tube. Okay, so this is it is the tube that having gas. Then we have the outside tube or bulb, glass bulb. Surrounds the arc tube to avoid shattering that could result from direct contact with water and other contamination or fluids. Okay, so we have some types of HID, high intensity discharge lamps. We have the mercury V4, we have the metal halide, the high pressure sodium, and the low pressure sodium. Okay, so talking about mercury vapor lamps, these mercury vapor lamps are the first commercialized and available HID lamps. High pressure mercury vapor light or lamps without color correction produce a blue-white light directly from their discharge arc or arcing. These lamps are constructed when the internal quartz, a small amount of liquid mercury is sealed in an argon gas fill inside the quartz tube here, no? So we have the gas here. Okay, the argon gas. Then okay, after the warm-up period, the arc emits both visible and ultraviolet light. Phosphor coatings inside here can be added to improve color rendition. Okay. So we have this another HID, the metal halide lamps. So metal halide lamps are constructed similar to mercury vapor lamps, except that it has a various metal halides added to mercury and argon in the glass fill. Okay, so additional metal halides, aside from having mercury and argon inside this glass. Okay, so we have also the high pressure sodium lamps. So you can see here, high pressure sodium lamps contain an internal arc tube made up of translucent ceramic here inside, ceramic material rather than quartz glass because of high temperature. Okay, so these are available in wattage ranging from 18 to 1000 watts. Then the arc tube is enclosed in an outer glass envelope like that HID lamps. Okay, so we have the low pressure sodium lamps. So this is just an example of low pressure sodium lamps. Okay, so a blended or a blend between HID and fluorescent technologies produce the monochromatic yellow light consisting of almost entirely of orange-yellow wavelength, So as you can see, the lamp has only one color, or we said, as we define monochromatic, as we said, So the excess sodium is contained in the arc tube because the glass may absorb or react with some of the sodium particles. Okay, so full light output does not occur immediately when power is applied. Okay, so this is all about HIDs. Now, another example of HID. Then we have the blended lamps. Okay, combine the luminous efficiency of the HID lamp with the good color rendering capability of incandescent lamp, and no start time, and thus total luminous flux is available immediately. So this does not wait that it will be heated, or the power will be increased, or no, the temperature will increase. No, it will be immediately render its capable or the available color. Okay. We have also the mercury tungsten blended lamps, The advantage of this mercury tungsten blended lamp, they are directly interchangeable with incandescent lamps and have a longer lifespan. Okay, so according to this base, it is also traded, and then you can replace this mercury tungsten blended lamp directly if you have already your incandescent receptacles or incandescent bulbs. Okay, so diretso-diretso lang yan, ma-control mo na, or ma-install mo na directly. Okay, but of course, the problem of this mercury tungsten blended lamp, this could not be dim, or can apply to dimming, Okay, so next we have solid state lighting. So we have these leads, the light emitting diodes. Okay. So light emitting diode semiconductor is a semiconductor that consists of a chip of semiconducting material treated to create a structure with two electron charged electrons. Okay. So an individual chip emits light in a specific wavelength. So the light source is near monochromatic. Okay. So the specific wavelengths or color emitted by a lid depends on the materials used to make the diodes. Okay. So as you can see, diodes will have different colors. You have the red, blue, and green. So this is recently this is very common in our lighting system. So the specific wavelength of color emitted by LED depends on the materials used to make the diode. Okay. So subject to sudden failure or burnout and have an exceptional long life, which is equal to 50,000 to 100,000 hours. Okay. So we have also the mercury content of lamps. Okay, let's go back here. Okay, so fluorescent and HID lamps have some mercury content. So that is why one of the problem if you will be using mercury lamps or mercury content lamps, mercury B4 as we used in the fluorescent lamps, the discharge of the waste of these lamps is should be monitored, because you are wasting, or you might contaminate water supplies, no? And as we know that mercury is very dangerous if it will be swallowed by any of us, no? Okay, so let us now discuss the forms of architectural lighting. This is 4.7. Okay, so we have here architectural lighting is a crucial to the performance of everyday activities and to the precision of the built environment, no? Basic function of light in interior building spaces. It could be ambient lighting, local lighting, accent lighting, and decorative lighting system. So we have here for the ambient lighting. Okay, as you can see here. So sometimes called general lighting, no, provides uniform illumination throughout the space and illumination for color and textures. So local lighting, sometimes called task lighting. Okay, so you can see an example here. These lamps is installed or are installed or were installed in the stairs, so that the passers here will not be pulled down, no? Okay, so you'll be able to see the steps of the stairs, no? So illumination provided by specific visual function can influence the effectiveness of the individual performing tasks. Then we have also this accent lighting, no? This directional lighting used to emphasize particular objects or area, emphasizing a particular architectural feature, place a piece of artwork, photograph, or plant, no? So this is one of the application of this lighting system. We call this one as accent lighting. Then we have also decorative lighting, no? So okay, these decorations here is lighted or are lighted here, so that we'll be able to see the additional beauty of our installations, or our it might be attractive to our clients and visitors. Okay, so next we have emergency and safety lighting. So it is just a secondary lighting system that provides backfill illumination when the power supply to the normal lighting system is interrupted. Okay, so if, for example, the utility turned off, or we have the blackout or brownout, then this emergency and safety lighting system will come in, so that still will be able to follow follow the directions, okay, on exit, the directed exit signs, no? Okay, so this includes emergency lighting, standby lighting, safety lighting, escape lighting, and exit lighting. So that is emergency and safety lighting system. So emergency lighting, no, requires the critical care and emergency species found in hospitals, police, fire protections, and crisis management areas. So this is an example of emergency lighting system. Okay, so we have also the standby lighting. So this will be enables normal activities to continue substantially, okay, unchanged, no, power by an emergency generator or battery backups. Okay. So we have also the safety lighting, no, ensures the safety of people involved in potential hazardous process. Okay. So this is an example of safety lighting system. So we have also this escape lighting, no. So this is to ensure that an escape route can be effectively identified and used in case of failure of normal lighting system. So we have these types of lighting system that will guide us or will give us a direction, especially when there is brownouts of our natural sources of light. Okay, so we have this exit lighting, no? So illuminated signage used to provide clear directions for an emergency exit of the building occupants. Okay, so that kind of lighting system will be separated. Okay, the sources, the circuit will be separated from the normal lamps that we discussed in the previous slides. So we have also this pendant, no? Pendant. It is a luminaire that is hung with a cord, chain, or tube that enables it to be suspended from a ceiling or other support. Okay, it broadcasts light over the entire space, no? So this is an example of a pendant system. Okay. So we have this traditional lighting installation also. Okay, so one of the common types of luminaire, as we said, is the pendant. We have common types of luminaire also, the uplight. Okay, uplight. So meaning to say that it is a luminaire where a shielded light source direct its light to the ceiling. So as you can see here, no. So their lighting system is directly towards the ceiling, where of course this light will be reflected by the ceiling towards the lower space or surfaces. So we have also this downlight, a luminaire that is usually attracted to or recessed in the ceiling and emits the concentrated light downward. Okay. So we have also the scones. Of course, these are decorative, wall-mounted, or even ceiling-mounted, no? So we have that. Then we have also the high hat. This is a type of downlight that is resist canister-shaped luminaires with a shielded lamp that emits light downward. So we have here, no? Okay. Then resist type luminaires and scone types luminaires. We have also these high B luminaires, no? So especially if we have the warehouse, the laboratory facilities, or factory, or manufacturing, or fabrication space or area, then you can use the high bay luminaires. Okay, so that it could not be reached or will be stricken by any materials now that we use in the production area. So these high bay luminaires, okay, are used in high ceiling areas, no? Okay, so 20 feet or above, okay, that require uniform illumination. High bay pictures installed in a grid pattern. Okay, of course, you have to arrange in a grid so that it could be the lighting system will be distributed equally. No, these luminaires are high wattage. Okay, of course, the fixture size of is fairly large, about 2 feet for a typical fixture. So it is just a suggestions, no? Okay, so we have also low bay luminaires, no? We have high bay and we have also low bay luminaires. Okay, so these are compact. They are designed for use in low to medium ceiling areas. Then we have also spotlights, no? Especially in a theater, okay, sa mga areas na we have we are going to present stage drama, stage presentations. We need to have these spotlights, no? It's a luminaire that is designed to emit an intense concentrated beam of light with usually no more than 20 degrees divergence or from where it is directed. Then we have also the floodlights here, a luminaire that emits an intense light that the broader than a spotlight, and that is capable of being pointed in any direction. Okay. So what else? So we have this directional lighting system. Okay, so is illumination where light received at the work places or plane or light illuminating an object. Okay, so we have this example of directional lighting system. Okay, so we have also the track lighting, no? The lighting system that will follow, or we have this tracking. This is a directional lighting installation where the luminaires are attracted to any movable along the metal track. Okay, so it will follow any person, okay, that is seen by this kind of luminaires, no? A more subtle method of directional lighting involves the use of one of the many differential resist type downlights. Okay. So we have also this diffused lighting system. So diffused lighting system. Okay, it is not focused, no? It will be we have to diffuse so that to reduce also the glaring amount of the lighting system. Lighting installation is in which the light on the working plane or on an object is not incident, okay, predominantly from particular direction. Diffuse light is cast and dispersed over a large area, okay, lighted area. So we have also diffuser, no? Light component such as translucent glass refractor that redirects or scatters the light from the source. We have also the cornice lighting, the cove lighting, which is now common in some installations, especially if it will render performances. No? We have here the balanced lighting system, okay, the fluorescent lighting, fluorescent luminaires. So we have all these common lighting installations. Okay, what else? The fluorescent luminaires here, example. Okay, so we have the lens also. So we have the fluorescent luminaires, parabolic louvered. No? So we have several types of fluorescent luminaires. Okay. What else? Do we have the trophel? Is a linear luminaire constructed of an inverted material through what that serves as fixture of for fluorescent lighting lamps. No, okay. So it is usually installed with an opening flush with the ceiling. So we have also the reflector lamps. No, okay. So an incandescent compact fluorescent or HID lamps with a built-in reflecting surface. So this is just a matter of determining the directions of the this reflection of the surface. No, okay. So two types of reflector lamps: the elliptical reflector lamps or ER. Okay, we have also the parabolic aluminized reflector PAR lamps. No, parabolic. Okay, this is more on it is either incandescent filament halogen filament tube or HID arc tube or pressed glass reflector. Okay, so what else? Remote source lighting installations. No, so this is now very common. No, in advanced lighting technology that can transport light from a single source over distance to one or more lighting outlets emits light evenly along the way. So these remote source lighting installations, you can manipulate these lamps, outlets, and any other devices connected to the system remotely. No, or just you can use your cell phone, try to install the driver, and then just simply manipulate this source lighting. No? So especially, for example, if you went to vacation, then you want that every night your lamps inside your house, no, your house will be lighted, so you can manipulate it remotely. No, so of course this time, of course, amount is bigger compared to an ordinary system. Okay, so we have two types of RSL: the fiber optic RSL. Okay, and we have also the line pipe RSL systems. Okay, so we have this for we shall say decorative installations. Okay, so we have this light distribution and glare. This is very important, no, because we cannot work efficiently if the lighting system is, your lamp is very glaring. No, so we will discuss first the distribution of light. Okay, in the candela or candle power distribution curve is a graphical representation that illustrates the luminous intensity around the cross section of the lamp luminaire. No, okay, so distribution of light also is a curve and a polar graph that shows the relative luminous intensity in candela around the lamp of luminaire. So we have also the correlational map of intensity measured inside. No, okay, we call this as candela. Then we have also this distribution of light, candle power distribution curve. No, it is heavy dark line, and the curve represents luminous intensity of various positions definite the luminaire opening. Okay, distribution of the unit is symmetrical. No, the curve in one plane is sufficient for all calculations. If the distribution of the unit is asymmetric, of course, such as with street lighting and fluorescent units, 3 or more planes are required. Okay, so we will try to we will try to redesign the whole system. Okay, So we have some categories of light distribution produced by luminaires. We have direct, okay? Luminaires, the light will be direct, no? 90 to 100% of the light is directed downward for maximum use. We have, of course, indirect, no? This is 90 to 100% of light is directed to the ceiling and upper walls, okay? So if the direct is 90 to 100% directly to the downward position, then indirect is in upward position. Of course, lights will be reflected in the ceiling. We have also the semi-direct, no, and the general diffuse direct or indirect. Okay, so we have here glare. No? It is excessive brightness in the field of vision that causes discomfort or extreme cases produce disability from a temporary loss of vision. Okay, so that is all about glare. It is a visual sensation caused by luminance that is sufficiently greater than the luminance to which the eyes are adapted. Glare can be irritant or impediment to vision. Okay, so to prevent the vision, the design of lighting installation that produce discomfort, the visual comfortability is calculated. Okay, so discomfort glare. This is one of the types of glare, no? Causes visual discomfort without necessarily impairing the vision. There we have the disability glare. We have the direct glare and the reflected glare. Okay, so for those who are being disturbed by this glaring, then try to control. Okay, so control glaring. So preventive glare requires special attention to future design. So we have this what they call as glare zone. Then we have also this the light is emitted into the glare zone. Direct glare and reflected glare are likely. So light emitted in the glare zone can cause visual discomfort. Okay, so positioning and selecting light fixtures. Then small spaces as a shielded light source and uplight directs to its light to the ceiling where it is reflected back to the surface or the space. Okay. Uplight also prevent color and glare and work well in larger spaces. Properly designed downlights use baffles to prevent light from being thrown into the glare zone. Okay, so we have that. So we have also lenses, no? Typically made for clear UV stabilized plastics and the rest of the function of that lenses. So then also the louvers. Okay, so this is slots in a light fixture that create openings for emitting lights or emitting diode. Okay, so we have baffles, no? Opaque or translucent elements that shield a light through from direct view, typically part of the light fixture, and so on and so forth. Okay, so let us proceed to illuminance and luminance. Okay, so luminance is the amount of light incident on striking a surface. Luminance is the amount of light leaving an object, thus relating to how bright an object appears to the human eye. So this is the luminance differentiate or the differences of luminance and illuminance. So luminance is a luminous intensity of a surface in a government direction per unit of projected area of the surface. Okay, so luminance can be expressed in two ways: candela per unit, lumens per unit area, and then the rest of the information about the luminance. Okay, so illuminance is the density of luminous flux striking a surface. Okay, so this describes how bright surfaces or how bright a surface may appear to the human eye. Okay, appropriate units of measurement for illuminance are the foot candle or lux. So we have this foot candle unit of measure illuminance. This is the oldest physical unit. Okay, so that is all about the illuminance. We have also the lux, no? This is the SI version of units, okay, for surveillance, which is 1 lumen of bright uniform illuminance, 1 square meter surface. Okay, so we have this example here. Try to analyze, not example, but conversion factor from candle to lux, foot candle to lux, so on and so forth. So recommended illuminance: large lighting installation that consumes a lot of energy. Okay, too much lighting that is not necessary in a building interior should be avoided. Okay, so avoid unused light sources, no? Lamps, bulbs. No? So this is a wasteful activity. So it's better to what we call this one, implement higher investment, maintenance and energy, so that sooner or later this could be recovered, no? So light output versus light intensity. So we have this light intensity measured in foot candles or in terms of lumens per square meter or lux. Okay, so we have this subtitle 4.11, Principles of Lighting Designs. Okay, so we have this basic design approach. Okay, the proper design of lighting installation requires use of 2 calculative procedures: computing illuminance from a point source or computing average illumination levels. Okay, so this is calculation of illuminance of specific points in a lighting installations, no? Is done to evaluate lighting uniformity, especially when using luminaires, okay, where maximum spacing recommendations are not supplied or where task lighting levels must be confirmed. Okay, so anyway, just try to use these principles, no? So we have symbols used in lighting and electrical system design. So the electrical design, the E is the common use for voltage and I for the current in ampere. Lighting design, E is used as symbol for illuminance. I is also used as the symbol for luminance intensity. Okay. So how you're going to compute illuminance from a single point source? So computing illuminance from a point is complex and generally involves computer analysis. The intensity of light traveling away from the source expressed as it gets over from the sources. And then we have this beam, the illuminance, and the surface as we will be working. No? So the zonal cavity method, the basic principle behind this method is that the foot candle at the work plane unequal to the flux over the work plane. Okay. 4 basic types or steps in any calculation of illumination level. So determine the cavity ratio, determine the effective cavity reflectance, the select coefficient of utilization, and compute average luminance level. Okay? So, room is made up of, okay, so we have this high ceiling, no? Okay, so we have the floor cavity, so on and so forth. This is just the representations or illustrations of these different cavity that we have: ceiling cavity and the room cavity and the floor cavity. So next, luminaire spacing. So once the number of luminaire required by uniform illumination has been determined, the luminaires must be arranged. Okay? So luminaires should be arranged, so on and so forth, so that we will be able to determine the systematic, or the we call this one the symmetric. Okay, so it should be the symmetrical location and sites in a given space. Then we should have to consider this arrangement or spacing of luminaires. So we have this we have this spacing criterion. Okay, this is the formula. Okay, so on and so forth. Okay, so we have this power density and power allowance, no? So we have this unit power density, or UPD, lighting installations, and the power consumed for illuminations in watts divided by the area, either feet square foot or a square meter. So this unit power density, or UPD, is expressed in watt per square foot or watt per square meter. It is frequently used as a measure of installed building lighting efficiency, or okay, so energy standards according to this professional organization. Okay, so this is either watt per square foot, or we have this unit watt per square meter. Power allowances are adjusted for type and characteristics. So we have to discuss also reducing the cooling load, no? So especially for the lamps or the ventilation or our air conditioning system, then we should have to consider reduction of cooling load, no? The intent behind the power allowance standard is to stimulate use of more efficient lighting, but it is also reduces a building cooling load by reducing waste heat. Okay, all of the energy consumed by lighting is converted directly as heat into the space. Therefore, in improvement of lighting system efficiency reduces the amount of heat that must be removed by the air conditioning system. Okay, so to reduce the energy consumption, of course, we will be using incandescent lamps. So, but of course, if we will be using incandescent lamps, then of course heat will be produced, more heating system. Okay. So what are the benefits of energy efficient lighting? So electricity required for lighting would be cut by at least 50%. Okay. So energy saving, in other words. Okay. Frequently a blended lighting solution with a mix of efficient lighting can be used to provide efficient ambient lighting and combined with lamps for good color rendition. Reduce annual carbon dioxide emissions. Okay, so carbon footprints, no? So reduction, sulfur dioxide emissions, nitrogen oxide emissions, other forms of pollution. Okay, so try to reduce all these hazardous solution. Okay, so we have this 4.12 lighting designs, practices, and considerations. So according to historic design practices, okay, so banks of light fixtures were routinely used to uniformly light classrooms, offices, manufacturing workspaces, and retail stores. Okay, so we have this architectural lighting design, both science and an art. and there is no single correct lighting solutions for all situations. The creative side of lighting design helps make the space aesthetically interesting and psychologically comfortable. Okay, so that is the most uh, responsibility of our architectural engineers, no? Then we should have to consider all the designs, the aesthetic forms and designs of the building. Okay. So we have this, no? So these are some of the example of the lamps that we used in the office or in a building. Provide a sufficient quantity of light to meet the seeing needs of the occupants that is not excessive. Okay. So we have this layered light and non-uniform balance use of types of architectural lighting tends to create. We have also the ambient lighting system and the task local lighting. Okay? So, for the task or local lighting, illuminates a specific visual functions can influence the effectiveness of the individual performing tasks. Okay, so focus light in a particular direction, okay, or area without casting any glare. Okay, so good task lighting makes work easier. We have also this accent lighting, no? Accent lighting. This is used to add drama and emphasis on particular object of area. This is more on architectural design. Low voltage halogen are excellent applications of accent lighting system. Okay, so they give us already an idea. And also this decorative lighting system. Of course, purely the installation of this kind of lighting system is more on aesthetic again, no? Aesthetic. The physical picture and the physical beauty of our construction, no? So these are some of the design considerations associated with lighting installation in common spaces. So we have these entrances. Okay, entrance or foyer is the transitional space from public to private and exterior to interior. Okay, so we have also offices and studies. These offices or studies, reading and writing require quality lighting that limits eye fatigue caused from glare. Okay, so we should have to consider our lighting system, especially if the area is that area is used for reading, writing, and other academic activities. Okay, so open the space can take advantage of special beautiful vista out the window and good natural ambient and daylight. Okay, computer requires special attention, so indirect lighting is not illumination and should be properly located. So restrooms and bathrooms, no? So these two rooms, the best light washes the face for all directions, opening and shadows. There should be sufficient enough light to see detail for grooming, but not so much to cause the glare and discomfort. Okay, quality lighting can be accomplished within any design style because there is a great variety in well-engineered fixtures. Okay, so what else? We have the dining spaces. Okay, so we have here the place where we eat our food, our snacks, no, so on and so forth. So dining spaces. So lighting should have food, table seating, and the people look attractive. So excellent color rendition is a must. Okay, so ambient lighting should be also considered. Okay, so dining tables feel isolated. A center pendant luminaire could be used in the table, no, in the dining table. So light level from the center pendant luminaire are chandelier. Okay, so it's good that they will be using chandelier. Okay, so we have also kitchen spaces, no? And the home kitchen lighting has become very important because this space has become central focal point. Okay, so just read the suggestions and the using that kitchen. Okay, so we have also this exit illumination and markings, no? So careful to the direction. It should be understood, no, the direction of uh, the uh, the direction of the exit sign, no. Okay, so building codes generally require that building exits be illuminated anytime that the building is occupied. Okay, with lighting having an intensity of not less than 1 foot candle of the floor walking surface level. Okay, so we have that. Exit illumination and markings. Okay, so this signage, no, exit signage should be simply mark exits or direct occupants to exit where the route is not directly apparent. No, so we should have to consider exit signages, and not only exit signages but also the markings, the directive markings, especially the place that we should go, especially if we have some calamities, no, like earthquakes, no, or landslides, so on and so forth. Okay, so we need to have to know the exit signages and the directions, no, not only the exit signages but also the directive signages. Okay, signages having directions. Okay. So we have also lighting system controls. So we have these different controls. There are switches, which is the most common, and the switch or group of switches. Common type of switches used in lighting installations: the single pole, single through switch. Okay, single pole, single through switch. That is the most common. Then we can use also three-way switches. No, is three, and four switches is four. If the location is more than having only we have two locations, then you can use three-way switch. If you have three locations, you can use two three-way switch and one four-way switch, so on and so forth. Okay. So three-way switches are, and one or more four-way switches are required to control this kind of examples that we have. So we have also dimmer switches. Okay. So for those who want that their light will be dim, no, become dimmer, then use these switches. Okay. And key-eyed switches, no, limit access to switches for lights and equipments to authorized personnel, no? So that this switch will not be disturbed or misused. Okay, so try to use these keyed switches. So the switch which will be having its own key, no, to open. Okay, we have the door switches, time clocks, electronic switches. Okay, when we say door switches, this is important, especially in a building, okay, or we have to activate the lighting system circuit when the door is open or closed. Okay, so if the door is closed, then the lighting system will be lighted, no, and if the other side, so the lighting system or the lights will be closed. We have also time clocks, no, can be used to control the time period that lighting installation operates. So we will use time system. Electronic timers, no, automatically control operations of a lighting installation with electronic components, so on and so forth. We have this photo cell control occupancy sensors. Okay, so especially in the outdoor, no, lighting systems, street lights, then you can use this photo cell. Okay, so we have that. Then occupancy sensors, no, control light installation by sensing occupants. Okay, so if the occupants of a certain rooms or area, okay, so pag mayroong motions, then this occupancy sensors will be activated. Okay, central lighting control system, centralized, no, control system for lightings, for outlets, convenience outlets, specialized or special outlets for aircon, so on and so forth. Then try to consider this central lighting control system. Okay, so we have also this daylight principles, no? So fundamental principles of daylight: the efficient and effective use of direct, diffuse, or reflected sunlight to provide full or supplemental illumination for building interiors during hours of sunlight. Okay, so daylight. And then we have also the sunlight. Excellent color rendition and brilliance diminishes the need for artificial light in buildings and thus saves lighting cost up to 80%. No? So that is by using natural lighting system. Effective of daylighting. Okay, daylighting in buildings also typically decreased space heating and conflict costs. We have some advantages of daylighting. Okay, so good for human eye. It tends to adapt more easily to daylight. The glazed surface needed for daylight gave the occupants to sense of contact with the outdoors, so on and so forth. Okay. So, but we have also these disadvantages of daylighting. The major disadvantage of daylighting is the unpredictable availability of sunlight. So, we cannot read the mind of the production of this. You cannot predict the availability of sunlight. That especially during storm or wet season, then daylight is now become a problem. Daylighting system. Okay, if not designed properly, oversized glazed areas that allow daylight into occupant comfort can also be adversely affected by uneven heating or cooling system. Okay, so what else? Okay, these are some of the examples: the direct light, okay, the reflected light, the diffuse lights. Okay, so we have this glazing, typically performance measure for the center of glass. For selected types of glazing are provided. Okay, so solar heat gain coefficient or SHGC. So we have also the lower SHGC. Okay, so that's why okay, we need to have this. We have to study this one because this will become an additional delay. It will result to additional delay of hours of the installations. No? So visible transmittance, BT, light to solar gain ratio, LSG. So some of the glazing materials, the glass, most of all, no, glass, the plastic. Okay, so the glass and plastic combined, no. Okay. So we have these daylighting strategies. Daylighting systems must be engaged to provide illumination or areas where it is most needed, and to do so without adversely affecting the occupant comfort. Okay, basic daylight strategy is to increase the number of size of glazed areas in the walls or ceilings for a building, but simply using large glaze openings does not ensure good good lighting. Okay, so we have these strategies, no? Okay, windows fenestration. Okay, so try to understand what is fenestration. It is a design terms that describes window size arrangement and glaze type arrangement also. It affects daylight, passive solar heating, space cooling, and natural ventilation. Okay, so we have this clerestory window system, and the atrium and clerestories and atrium. So we have this clerestory window system, and we have this fenestration arrangement of several smaller windows can provide uniform daylight illumination. It properly distributed and the space being illuminated. Cold climates, northern hemisphere, low positions of the south facing window. Anyway, these are some of the very common suggestions in the installation. No? So, east and west facing windows. Consider also this one in a building. Okay. So, we have north facing windows, especially for those who are still functioning. Okay. So, we have the skylights, no? Transparent panel located in a roof opening that allows direct and diffuse sunlight into the building. So this is more on the roofing design. We have also the skylights. It is a transparent panel located in a roof opening and allows direct and diffuse sunlight into the building. Commonly made from glass composites, plastic, and plastic composites. We have this roof monitoring. Just follow this one. Okay. So what else? We have some the advantages of skylights, no? So we have some of the advantages of the skylights. Major disadvantage of the lighting is the unpredictable available of sunlight. If not desired property, oversized glaze, blah blah blah. Okay? Occupant comfort can also be adversely affected by uneven heating or cooling and glare them from direct sunlight. But of course, we have also these disadvantages of skylights. No? Large functional fluctuations. No? Large fluctuations in illumination intensity caused by movement of clouds across the sun. Okay, so that is very important, skylighting. Okay, so reflective light shelves. So it's a passive, non-mechanical architectural element of mechanisms that allows us sunlight to enter deep into a building. Okay, so just read the other content. No? We have also the light pipes. Most commercially available light pipes consist of an exterior roof-mounted transparent dome and reflecting metal pipe and diffuser. So this is very important that we should have to consider these light pipes because that sometimes our materials could be easily damaged. Okay. So sun tracking light pipes. Okay, so sun tracking, no. So it will just follow the direction of the source of lightings. We have also the fabric roof membranes. Now, translucent fabric roof membranes can be used to introduce the light through the roof itself. Okay. What else? The fabric roof members. Okay, so those are the most important thing when it comes to study light and architectural lighting systems. So thank you for watching. Thank you for listening. Thank you for having these discussions.